Hi everyone, my name is Ishan, and today I'm going to be talking to you about the different types of wheels and drivetrains you can use on your robot. So first, let's talk about the wheels. And this is a Tetrix Max Wheel. It's a common wheel included in your kit, and it doesn't have any special features about it. It can roll forward and backward. It doesn't have any rollers, so it can't move side to side, although it can turn in place. And it's a very robust wheel, and it's very reliable, which is why a lot of rookie teams use it in their drivetrains to make for a very stable robot. Next, let's talk about the Gyro Wheel, another wheel included in your kit. And this wheel also has the same basic capabilities as the Tetrix Max Wheel. It can roll forward and backward, and it can turn in place. However, it has rollers that are situated perpendicularly to the way the wheel turns, and this allows it to slide side to side on a robot. And when you use this gyro wheel with other gyro wheels, then it can make for a robot that is very versatile and fast. Or if you use it in conjunction with some Tetrix Max wheels, then you have a robot that can turn along its axis, because this wheel can turn like that along a curve. However, this wheel is thin and it can't support much weight at all, which is why most teams when they're using gyro wheels, they use two at once, so that it can at least stand up by itself as compared to this one. This one just by itself. And next we have the last wheel that we're going to be talking about today, the Mecanum wheel. And the Mecanum wheel is it has a lot of the advantages of the Tetrix Max wheels and the gyro wheels combined, which make it a popular choice for a lot of slightly more advanced teams. So it features a metal design, which makes it a very, very robust, and it's also a bit thicker than the Tetrix Max wheel. And again, it can move forward and backward, and it can also turn in place. And however, these rollers on the Mecanum wheel are at a 45-degree angle as compared to the 90-degree angle that the gyro wheels are on, which means that if you try and slide this wheel sideways, it doesn't just slide in place. So let me demonstrate. It actually turns. You saw that it actually turns while it's sliding. And that means that in the drivetrain section, I'll talk more about this, but if you arrange the Mecanum wheels in a certain fashion, then you can actually get the robot to strafe sideways in place. So now that we've finished talking about the wheels, let's talk about the drivetrain. Now the drivetrain is essentially the general outline of your robot, as well as the position of the wheels. And in this case, because we're going to be talking about mostly the movement aspects of the drivetrain, the position of the wheels is important here. So what I have here is a standard drivetrain, and this drivetrain features two Tetrix Max wheels and two Omni wheels. And usually teams with this setup have motors connected to both of these wheels, but not to these wheels, and these ones are free rotating. So what this robot can do is, with the combination of all these wheels, it can move forward and backward. And then when the robot when the robot gives power to these two wheels in opposite directions, then what happens is that it can turn like this. So the center of where the axis about which the robot rotates is right in the middle of this line. Because these wheels are free rotating and these ones are Tetrix Max wheels, it rotates like this about this axis. And this robot, so again, it's very robust because it has some Tetrix Max wheels over here. However, it can't strafe sideways, and it can't move diagonally, which is why many teams choose to go with other options such as the Holonomic Drive or the Mecanum wheel setup. So you've seen the standard drive and the Holonomic Drive. However, this Mecanum wheel drive combines the best aspects out of both of them. So you'll see that these front two wheels and these back two wheels are both Mecanum wheels. And because they're arranged in a certain fashion so that the rollers, so you can see these front two wheels, they make a sort of X shape along with the wheels in the back. So here's a better view. You can see that these rollers point this way towards the center of the robot, and these rollers also point that way. And on the opposite side, this is true also. So in addition to moving forward and backward, and oh darn, I messed that up. Okay, I'll just try again. So now that you've seen the standard and Holonomic drives, this is the Mecanum wheel drive, and it combines the best aspects out of both of those two drivetrains. And you can see that there's Mecanum wheels on all four sides of the robot, and they are arranged in a certain fashion so that the rollers on top, you can see a little bit over here, but the rollers on top always point towards the center of the robot. So you can see that these two point this way, and they sort of make an X shape. And now, so in addition to moving front and back, this drivetrain can also turn in place similar to the Holonomic Drive, like so. And the special thing that I mentioned earlier was that it can strafe sideways without needing to turn at all. So here, you see it, and then here's it rotating to the left, or here's it strafing to the left again. And there's a special combination of making the wheels turn. So on the side that it's moving towards, the front wheel needs to turn inward, and the back wheel also needs to turn inward as well. So like this, and then so you can see that in action. And then on this back side, on the side that is away from the direction of movement, both the wheels need to be turning outward. So there you have it. You've seen the three main drivetrains that your team can use, and each one of them has their pros and cons, such as cost, versatility, and stability. And with these options, you can pick the best one for your team. Next up, we have the Holonomic Drive, and instead of having two gyro wheels, it has all four of the wheels as gyro wheels, and they're oriented at 90-degree angles instead of them being in sets of two on the sides. And this allows it to, because it has 90-degree rotational symmetry, so it can actually move forward and backward by having all the wheels rotate forward, and then you can also do the same sideways and also backwards as well. And then by having only two opposite wheels rotate, it can move diagonally and then diagonally in the other direction. And then of course it can also turn in place. So this drivetrain is extremely versatile. However, it can be hard to control in a match because you also have to keep track of the orientation of the robot. And also because all these wheels are gyro wheels, it is quite easy for a robot to ram into it, and then the robot's orientation gets altered, which makes it hard to control in the match. But overall, if you want a speedy and versatile robot, then this drive is the way to go.